Today, we are going to discuss about exponential notation. So if a is any real number and n is a positive integer, then the n power of a is a raised to n. And that a raised to n can be written as a times a and so on until a, or we could say n factors. So the number a is called the base and n is called the exponent. Let us discuss now the laws of exponents. So number one, we have a raised to m times a raised to n. If we are multiplying the same base, then we are going to add the powers or add the exponents. So to multiply two powers of the same number, add the exponents. Number two, this is a division. So a raised to m over a raised to n. So to divide that one, we are just going to subtract the exponents if the base are the same. So to divide two powers of the same number, subtract the exponents. For number three, we call that one as power rule. To raise a power to a new power, multiply the exponents. Okay, such as this. We have a raised to m and that quantity raised to n. So that's power to a power, multiply the exponents or powers, then copy the base. So for example, we have 3 squared, quantity 3 squared raised to 5. So multiply the powers, 2 times 5 is 10 and copy the base, therefore it becomes 3 raised to 10. So if the result of that is really big, then do not give me the answer. Just write only the answer in terms of exponential form. Okay, and number four, we have to raise a product to a power. You have to raise each factor to the power. So we are just going to use distributive property. Since the base here are two variables such as a and b, and that quantity is raised to n, so using distributive property, that can be written now as a raised to n times b raised to n before you are going to simplify. So in this case, I have now 3 times 4 to the power of 2. You need to distribute the powers of 3 squared times 4 squared. So if you're going to answer that one, 3 squared is 9 times 4 squared is 16. So that is now 9 times 16. So we have 144. And 3 times 4 is 12. And 12 squared is also 144. So they are just the same. And then the fifth one, to raise a quotient to a power, raise both numerator and denominator to the power. So for example here, we have a over b to the power of n. So this is almost similar to number 4. That's only a multiplication on the base. And on the base here for number 5, that is in a fraction form or division. So just distribute the power. It can be written now as a raised to n over b raised to n. So for number 6, to raise a fraction to a negative power, invert the fraction and change the sign of the exponent. Okay, so we have a over b to the power of negative n. Again, it says here that to raise a fraction to a negative power, we are going to invert the fraction and change the sign of the exponent. So meaning to say, the numerator becomes the denominator and the denominator becomes a numerator. Then you write now the exponent into a positive sign. So like for this, a over b to the power of negative n. So we interchange the position of the numerator and denominator. It becomes now b over a. And then we write now the positive number. Okay, and lastly, for number 7, to move a number raised to a power from numerator to denominator or from denominator to numerator, change the sign of the exponent. So, for example here, we have a raised to the power of negative n over b raised to the negative n. So, to avoid seeing or looking the exponent of negative, then we have to interchange the position of the base. So base here is a is negative exponent. So write that one in the denominator. Then the b to the power of negative m, you also have to move that one to the numerator. Okay, so we're just moving the position or exchanging the position from numerator to denominator or denominator to numerator. Okay, that's now b raised to m over a raised to n. So using the law of exponents, so let us try to answer these exercises. So we have x raised to 4 times x raised to 8. So this will be now applying property number 1 or the product rule. So we have x to the power of 4 plus 8. So if we are multiplying the same base, add the exponent. So therefore x to the power of 12. So for this, I have y to the 4th times y to the power of negative 9. So applying first multiplication law of exponents, since the base are the same, so we can just add the exponents. We have y to the 4 plus negative 9, or that is now y to the power of negative 5. Since the exponent is negative 5, then avoid writing the negative exponent. Therefore, it can be written now as the reciprocal. So where the reciprocal of that becomes now 1 over y raised to 5. So another solution for that is in this form. So we have y raised to 4. Since this one that is in the numerator and whose exponent is negative, then we will write that one into a denominator. But we have to change the sign. So therefore 1 over y raised to 9. And then multiplying that one, we have y raised to 4 over y raised to 9. So in this case now, we are using the division law of exponent. We know that division law of exponents, having the same base, we have to subtract their exponents. So therefore, it becomes now y raised to 4 minus 9 is equal to y raised to negative 5. So they are now the same. Therefore, we also have the same answer as 1 over y raised to 5. Okay, number 19. So it's almost similar with number 18 after we rewrite y to the power of negative 9. So therefore, we have the same base, subtract the exponents of this. We have a to the power of 10 minus 6. Therefore, a 10 minus 6 is 4. Therefore, the answer is a raised to 4. Okay, for this, we are going to apply power to a power rule. So we have b 3 times to the power of 3 times 5, and 3 times 5 means 15. So therefore, b raised to the 15th power. And next number, we have 4x to the power of 3. So we have the factors in the base. Therefore, we are going to distribute the powers to each factor. So we can be written now as 4 raised to 3 times x raised to 3. Simplifying 4 raised to 3, we have 4 times 4 is 16, and then 16 times 4 equals 64. So therefore, 4 cubed means 64x to the power of 3. And number 22, we have 2x over 3. The quantity of this will be raised to the power of 5. So we are going to distribute the powers to each term. So we have 2 raised to 5 times x raised to 5 over 3 raised to 5. And then simplifying 2 raised to 5 means to say 2 times 2 times 2 times 2. I think there are 5 times already. Therefore, 2 raised to 5 means 32. So we have 32 of x raised to 5. And what is 3 raised to 5? That is 243. So we have 2 over 243. Take note, 2 raised to 5 over 3 raised to 5, we cannot subtract the exponents, or we cannot apply quotient rule or division law of exponent, since the base are different. Take note, we can only subtract or add the exponents if the bases are the same. Next, we have to simplify expressions with exponents. So for number 23, we have 2a cubed b squared. The quantity of that will be multiplied to the quantity of 5ab 4 to the power of 3. So I need to simplify first this factor by using distributive property to the powers. So I will copy the first factor of 2a cubed b squared times. So using that distributive property to the powers, it becomes now 5 cube a cube and b to 4 times 3. That's power to a power rule. Multiply. We have 12. All right, so we have to multiply now the numerical coefficients. We have 2 and 5 cube, but 5 cube means 125. So 125 times 2, it becomes 250. So we have here 250, and then copy the same base of a. Since this is now multiplication law of exponents, add their powers. So the powers is 3 and 3, so a total of 6. And then the next variable is b. So add the powers now of 2 and 12, it becomes 14. Okay, take note, in multiplication law of exponents, we only added the powers. Okay, for next number, we have the number 24. So we are going to simplify first the second factor by using distributive property on the power. So I will write the first factor of x over y raised to 4 times y to the power of 3 times 4 is 12, and x raised to 4 is x raised to 4 over z raised to 4. We have z raised to 4. Now that's the time we're going to multiply. So I'm multiplying this one. I'll multiply now numerator by numerator as well as denominator by denominator. So x raised, I will use distributive property on this as well. I forgot. So I write x over x raised to 4 over y raised to 4 times y raised to 12 x raised to 4 and z raised to 4. So multiplying that one now becomes x raised to 8 because we are going to add the powers, and then y raised to 12 because there's no y on the first factor. So just copy only that. Just copy that one. And then this one now we have y raised to 4 and z raised to 4. But take note, the numerator, we have a numerator of y and we also have a denominator of y. So therefore, we can apply the division law of exponents in terms of y for that item. So therefore, we can write now uh, x raised to 8 and y raised to 12 minus 4, because in division law of exponent we subtract their exponents. That's why we have 12 minus 4, and the remaining term in the denominator is z raised to 4. So we have now x raised to 8 and y raised to 8 because 12 minus 4 is 8 over z raised to 4. So that's the final answer for that problem. Okay, this is the last slide. We have simplifying expressions with negative exponents. So eliminate negative exponents and simplify each expressions. So we have 6mn to the power of negative 4 over 2m to the power of negative 2 and squared. So I would like to solve this map in this way. I'm going to apply division law of exponent. So we have 6 divided by 2 is, I will just write 6 divided by 2 times m of m. Now the exponent here is 1, so write 1, and then m here is negative 2, so I'm going to subtract minus negative 2, and in terms of n, I have n of negative 4 minus, the exponent here is 2, therefore n, we have negative 4 minus 2. Now simplifying that one, 6 divided by 2 is 3, Then I will write m and simplify now the exponents. 1 minus negative 2 is positive 3, and n to the power of negative 4 and minus 2 is negative 6. Then avoid writing negative exponents because we are asked to eliminate. Therefore, I will write n to the power of negative 6 in the denominator. So therefore, we have 3m cubed over n to the power of 6. And for number 26, can apply the property of number 6. This one, a over b to the power of negative n. So therefore, I'm going to interchange the position of the ratio form. So therefore, I can write now as 3z raised to 4 over y, and then open and close quantity to the power of 2. And then you simplify further by using power rule. We have 3 squared z raised to 4 times 2, and then we have y squared. Or we have now 3 squared is 9, z of 4 times 2 is 8, so z to the power of 8 over y to the power of 2. There's another solution for number 25 if you are going to apply the property. So I will just show to you another solution for number 25 using the property. Another solution. We have 6m n of negative 4 over 2m of negative 2 n squared. So other solution for that. So I will write for 6m times the m of negative 2 from the denominator. If I'm going to write that one in the numerator, it becomes now m squared. Then we have n of negative 4. To avoid negative 4, I will write it down in the denominator. Then the exponent becomes positive. So I have n to the power of 4 times the other term is n squared. So simplifying that one, we have now, but I still have a numerical coefficient of 2. So we have 6 over 2 is 3. And then m times m squared is m cubed. And then n to the fourth power times n squared, we have n to the power of 6. As you can see, the answer are just the same. So it's up for you now, which solution do you like best? But the answer is just the same.